All right, hello everybody. Today we are doing our 1.3 distance between 2 points set of notes. Up at the top here we have a review of the Pythagorean theorem. Hopefully we learned this a little bit last year, but just in case, we have the formula up here and we're going to talk about it real quick. All right, so for the Pythagorean theorem, we can only use this whenever we have a right triangle, okay? A right triangle must consist of a 90-degree angle. So I'm highlighting it in yellow here. And your legs are what make up this right angle. So A and B are your legs, and C is the hypotenuse. The hypotenuse is always directly across that 90-degree angle. And the Pythagorean theorem formula is A squared plus B squared equals C squared. So we're going to take this formula, and we are going to apply it to the first three examples. All right. So for number 1, the first thing I'm going to do is I'm going to highlight my right angle. Okay, my legs are what create this right angle here. So I'm going to label 9 as A, 12 as B, which means X is my C. C is directly across the 90-degree angle. C is our hypotenuse. And we're going to write it down in the form of A squared plus B squared equals C squared. So A squared is 9, so that's 9 squared, plus B squared, which is 12, so that's 12 squared, equals C squared, which is labeled as X. So plus or equals X squared. Okay. From here, we're just going to simply evaluate. Okay. So we have 9 squared. 9 times 9 is 81. And 12 squared is 144. Equals X squared. And 81 plus 144 is 225. So we have 225 equals X squared. Now, the goal is to get X by itself. When we're solving equations, our goal is to get the variable by itself. So we're getting X by itself. So the opposite of squaring something is to square root. So I'm going to square root, and I'm going to write X equals. All right. So if you need to take a moment and pause this video, I made 2 previous videos on how to use my calculator. So if you want to pause this video and learn how to use the square root or the radical symbol on your calculator, pause it now. Otherwise, I've written up at the top of our notes here a website that you can go to on your Chromebook, desmos.com/scientific, and it will help. It has the square root symbol, and we can use a calculator on our computer. So I'm going to show you how to use that one. So I'm going to go to my Google, and I'm going to type in the square root of 225, and I hit enter, and our answer is 15. All right, so X equals 15. Now remember, the hypotenuse is the largest side of a right triangle, so X in this case needs to be larger than 9 and 12, and in this case it is. So 15 sounds like a great answer, and it's also an exact answer. All right, so I would pause this video, and I would try 2 and 3 on your own. But if not, here we go. All right, so I'm going to highlight my 90-degree angle first, and I'm going to connect my legs. My legs are what creates the 90-degree angle, and those are my A's and B's. So I'm going to say 10 is A, 24 is B, which makes X our C. C is the hypotenuse, which is always across the 90-degree angle. So up top here, I'm going to write 10 squared, which is A, plus 24 squared, which is B, equals X, which is our C. So A squared plus B squared equals C squared. So we have 10 squared. We should know that that is 100. 24 squared is 576. And when we add those two numbers together, we get 676 equals X squared. And then again, the goal is to get X by itself. So we're going to square root both sides. And let's see what we get. So we're going to take the square root of 676. And we get a whole number. We get 26 is our final answer. So X equals 26. 26 is the hypotenuse. So it must be larger than the legs. And 26 is greater than 10 and 24. So we're all good. All right. Up next, again, I'm going to highlight my right angle, and my legs are what creates the 90-degree angle here. So 7 and 3 are our A and our B. So I'm going to put A, B, which means X is our C. C is our hypotenuse. and it is directly across the 90-degree angle. So we write a squared plus b squared equals c squared, so that's 3 squared plus 7 squared equals x squared, where 3 squared is 9 and 7 squared is 49, and when we add those two together, we get 58 equals x squared. And then to get x by itself, we must square root both sides. And our answer is going to be, oh look, it's a decimal. That's okay. Decimals are numbers, okay? So what we're going to do is we are going to round to the nearest tenth. So I'm going to look, tenths place is the first place after the decimal. So I'm going to look at my 1, and I'm going to ask myself, does my 1 round my 6 up? And that answer is no. So I'm going to write down my answer for x is 7.6. So we'll say x is approximately 7.6. And then we're going to double check. The hypotenuse has to be larger than the legs. So if I look at A, which is my 3, 7.6 is greater than 3, so far so good. And then let's look at our B. 7.6 is greater than 7, so we're good on that too. So x being 7.6, or approximately 7.6, is great. All right, so we are going to move to the next example. So now we have a triangle, particularly a right triangle on a coordinate plane. Okay, so what we're going to do is we're going to find the length of each segment below. So I'm going to highlight our first segment. I'll highlight it in blue. Our first segment is going to be RS. And all we're going to do is count from one endpoint to the other endpoint. So I'm going to count over 1, 2, 3, 4, 5. So RS has a length of 5. And then I'm going to count vertically from T to S. And I'm going to count from one endpoint to the other. 1, 2, 3, 4. So TS has a length of 4. And then our last side that we need to find is from R to T. Okay? Now, we cannot count from R to T because on a coordinate plane, you can only count horizontally from left to right, or we can count vertically up and down. We cannot count diagonally because it does not go through the squares evenly, or the grids evenly. So we are going to use the Pythagorean theorem, like what we did up at the top, to solve for this missing side. Okay? So we have our right angle here. Our legs created that right angle. So we have a squared plus b squared equals c squared. So I'm going to say a is 4, b is 5. So we're going to have 4 squared plus 5 squared equals x squared. 4 squared is 16, and 5 squared is 25, and we're going to add those two numbers together, and 16 plus 25 gives us 41. So we have 41 equals x squared, and then again, to get x by itself, the opposite of squaring something is to take the square root. So we're going to take the square root of 41, and that's going to give us a decimal. We're going to round it to the nearest tenth, so x is going to be approximately 6.4. Now you just need to double check, does 6.4 make sense in terms of this situation? Is the hypotenuse from R to T, is it the largest side? Is it greater than RS, which has a length of 5, and is it greater than TS, which has a length of 4? And that answer is yes, so 6.4. And we'll just go ahead and change that equal sign to a little approximated sign because that is not an exact answer. All right, in the next example, we have a diagonal line drawn for us, okay? And it wants us to find the distance between those two endpoints. So what we're going to do first is we're going to figure out what those endpoints are, okay? So I'll highlight my x and my y-axis. My x-axis moves from left to right. Y-axis moves up and down, okay? So the first coordinate point that we come to has a coordinate point of 1, 0, where we're at 1 on the x-axis and 0 on the y. So put 1, 0. And then our second endpoint that we come to is at 4 on the x-axis and then up to 5, so 4, 5. Okay. It says, what are the lengths of the legs? So we're going to take this diagonal line and we're going to create it into a right triangle. So remember, we can always count from left to right, so I'm going to create my right triangle. I'm going to highlight it in pink here. So it says, what are the lengths of the invisible legs? So from the horizontal line from left to right, this purple one, that I'll try to darken a little bit more. The length of this purple one is 1, 2, 3. And the length of the pink one, the vertical one, 1, 2, 3, 4, 5. So those are the lengths. We'll just say 3 and 5. And then it says, what is the length of segment D? So the original line that they gave us, and I'm highlighting in green, it wants us to find the length of it. So we are going to, again, use the Pythagorean theorem to solve for D. Okay, where A and B are our legs that create the 90-degree angle, and our hypotenuse is our C. So we have 3 squared plus 5 squared equals D squared. 3 squared is 9, and 5 squared is 25. 9 plus 25 is 34. And then our goal is to get D by itself. So the opposite of squaring something is to take the square root. So we do square root of 34. And again, that's going to be another rounded answer. We're going to get 5.8. So D is approximately 5.8. And this is greater than the lengths of each leg. So we are good. We're doing good. Okay, I would like for you to take a moment, and I want you to pause this video and try the next problem. It looks just like the one that we just did. Pause the video and try this next one. All right, this first endpoint that we come to is -3, 4. And the second endpoint we come to is 1, -2. It says, what are the lengths of the invisible legs? Okay, so I'm going to create a right triangle based off of this diagonal. So I'm just going to do my vertical and my horizontal line to create my right angle. Okay, so on the x-axis, I'll count 1, 2, 3, 4. So horizontally, our length is 4, and then vertically, 1, 2, 3, 4, 5, 6. So 6 is the vertical. So 4 and 6. And then it wants to know the length of the given segment, so the segment that they originally gave us. Okay, we'll call that x. So we'll do the Pythagorean theorem again. A squared plus b squared equals c squared, where a and b create the 90-degree angle. So a is 4, b is 6. So we have 4 squared plus 6 squared equals x squared, where 4 squared is 16, and 6 squared is 36. And when we add 16 plus 36, we get 52 equals x squared. And then to get x by itself, we take the square root of both sides. And this one is going to be another decimal because 52 is not a perfect square. So we'll hit the square root button, type in 52, and hit enter. And rounded to the nearest tenth, we get approximately 7.2. So x is approximately 7.2. So the length of the given segment is approximately 7.2. All right, and then it asks to find the distance between the two given points. So take a moment, pause the video, and go ahead and plot 2, 3, and -3, -4. So take a moment and plot those points, pause the video. And then we're going to do the same exact thing. We're going to create our right triangle. And then we're going to find the length. So 1, 2, 3, 4, 5. So horizontally, the length is 5. And then vertically, 1, 2, 3, 4, 5, 6, 7. Okay, and it wants us to find the length of the distance between those two. So we'll call it x. And then we'll do the Pythagorean theorem again. So we have 5 squared plus 7 squared equals x squared. 5 squared is 25. 7 squared is 49. And when we add 25 plus 49, we get 74 equals x squared. And the opposite of squaring something is to take the square root. So we get x is approximately, and then we're going to type this in our calculator. Oop. It's approximately 8.6. Okay. All right, so we've been using the Pythagorean theorem to solve for the distance between two coordinate points. Okay? There is also a distance formula that you can use. Okay, so you have two ways that we can find the distance between two given points. So the distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? And remember, all the coordinate points are always in the form of x1 and y1, and x2 and y2. It's always in the form of x comma y. Okay? So when we use the distance formula, we need to make sure that we are substituting everything into the appropriate spaces. Okay? So we'll show how to use the distance formula, and then at the end you can decide which one you want to use. Do you want to use the distance formula, or do you want to use Pythagorean theorem? Okay, so it says, what is the length of the segment MB if M is located at -3, 4, and point B is located at 2, 5? Okay, so to find the distance between these 2 points, the first thing that we want to do is we want to take the difference. Difference means subtraction in math. So we want to take the difference of our x values and then square them, and the difference between the y values and square them. Add those two numbers together, and then we'll take the square root of the symbol. So I'll even write it down. So we'll say d equals the square root, and we'll say difference of x's squared plus difference of y's squared, and then we'll take the square root of those numbers. So for this particular problem, the difference of our x's, so our x values are -3 and 2. So I'm going to figure out, I'm going to type it in my calculator, -3 minus 2, and that gives me -5. I'm going to keep it in parentheses. So that's -5 squared plus the difference in my y's. My y's are 4 and 5. So I'm going to do 4 minus 5, and that gives me -1. So I'm going to put in parentheses -1 squared, and then we're going to take the square root of that answer. So -5 squared. Remember, you must put it in parentheses in your calculator, otherwise it will not do it correctly. So -5 squared is -5 times -5, which gives you +25, plus -1 squared. -1 times -1 is +1. We're going to continue to simplify it underneath the radical symbol, and then we'll take the square root. So 25 plus 1 is 26, and then we're going to take the square root of 26, and we'll have to round to the nearest tenth for this one because it's not going to be a perfect answer. So D is approximately 5.1, approximately 5.1. Okay? You can take your time and you can use the formula if you want. It does not matter to me. But I would say the difference of my x's squared plus the differences of my y's squared. Add them together and then square root. So that's exactly what we're going to do. Flip it on over. And then it says use the distance formula to find the distance of the line segment shown below. So first things first, I'm going to highlight my x and my y axis. And then I'm going to figure out my coordinate points. Okay, the first coordinate point that I come to is at -5, 3. And the second coordinate point that I come to is 1, -4. From here, I'll just write down my coordinate points, -5, 3, and 1, -4. And then remember, it's the difference of our x's squared plus the differences of our y's squared, and then we're going to take the square root of that. So I'm going to highlight my x's. So -5 minus 1. -5 minus 1 is -6. And that's going to go in parentheses. So -6 squared plus the difference of my y's, 3 minus -4. 3 minus -4, that gives us a +7 squared. And that's all underneath the square root symbol. So remember, -6 squared is a negative times a negative, which is a positive. So that is going to be 36 plus 7 squared is 49. 36 plus 49 is 85. And we'll round that to the nearest tenth to get the distance for the segment shown below. So we have the square root of 85, which is approximately 9.2. All right, we have 3 more examples, and then we'll be done with notes. Okay, so it says find the length of the segment between the coordinate points. So this time it's not on a coordinate plane. So again, we'll do the difference of our x's. So that is 2 and -9. So I'm going to do 2 minus -9. And that's going to give us +11. Put those in parentheses, squared, plus the differences of our y's. -7 minus 8, which gives us -15. That's going to go in parentheses, squared, and then we're going to take the square root of this at the very end. So 11 squared is 121. 15 squared, or -15 times -15, which is positive, is 225. And when we add 225 plus 121, we get the square root of 346. And we'll round to the nearest tenth. And we will get 18.6, approximately 18.6. All right, take a moment, and I want you to solve for these next 2 problems. Difference of our x's plus the difference of our y's and then we're going to add them together and then take the square root. This time, the square root of 16 is a positive answer. So we get, not positive, a whole number answer. So we get 4 for this one. And then for our last one, again, difference of our x's. Difference means subtraction. 8 minus -1 gives us 9. Squared plus the difference of our y's. Difference again, subtraction. 5 minus 3 is 2. And once we add those together, we'll take the square root. So 9 squared is 81. 2 squared is 4. And 81 plus 4 is 85. And we have already taken the square root of 85 already on this set of notes. but we'll do it again. The square root of 85 is approximately 9.2, which was the top left example, but no worries. All right, that's the end of your notes. If you have any questions or concerns, please come see me during advisory. I hope you guys have a great day, and go Rebels.